We're going to quickly go over chi-square analysis again, just with some of my own data so you can see. Now, it's easiest if you do one for each different type of trait. So I'm going to copy this here and paste it and use one for wings and one for eye color. So when we're looking at this, you can either do F1 and F2 generations or just the F1 generation, depending on what data you have. I'm going to show you how to do it based on just the normal and vestigial wing, not the eye color. So here is the copy that I have actually, I'll see if I can put it down here, I have actually copied into my spreadsheet. I showed you how to do that on the last video. And there is my F1 and F2 generations. So for F1 I had 14 and 17 normal wings and no vestigial wings. I'll put that in. Sorry. So for my F1 generation, and this is going to be for category wings, I had 14 and 17 observed, and we are saying that they're not sex linked. So it's going to be 31, and that was normal wing. And for my F1 generation vestigial wing, I had 0 observed. For my F2 generation normal wing, now note we didn't do this in class, but if you do have the data for F2 and you wish to add it in, you can. We're going to put in that data as well. For normal wings here we had 14 there, 13 there, and vestigial I had 4 and 4. (14 plus 13), wasn't it? And vestigial equaled 4 plus 4, which was 8. Now we have to do expecteds, and this depends on your Punnett squares that you would have done above, and I haven't actually gone in and put them down, but you actually have to work out your percentages, and you did this not only in your Punnett squares but also in our hypothesis. So let me just work that through quickly and I'll speed up the video. Now for F1 generations we expect to have 100%, that's 100 out of 100, that's how you put 100% into a fraction. We expect 100% of all of our flies to show normal wings. And so we have to have actual numbers here. So if we had in total 31 flies, that means I need 100% of 31, which is 31. And the expected for the vestigial would equal 0% of 31, which is 0. Now, in the F2 generation, I expected to have 75% normal and 25% vestigial. Now, in total here, I have 27 plus 8 equals, combined, I'm just going to add a little note here, 27 plus 8 equals 35. So that's my total number of flies. So I need to know my expected value will be 75% of 35 for my normal wings and 25% of 35 for my vestigial wings. So equals 75 out of 100 times, and the total number of flies I had was 35. We expected 75% of 35. See here, 75% of 35 to be normal wing. I expected 26.25. And here again, I expected for vestigial ring 25%. So 25 out of 100 times by 35 flies. I expected them to be vestigial. So I'm a little low on the vestigial and a little high on the normal. Now, we're going to now take those numbers and put them into here. You can actually round them up, but given that it's Excel, I don't think I'll need to worry about that. This says that we need to do our observed minus our expected, and then we square it, and then we divide it by our expected results over here. So the easiest way to do it is equals my observed minus my expected, done. Because there was no difference between my observed and expected. This is what is the difference between my observed and my expected numbers. Now, if you type this in and you've typed it in correctly, you can actually copy down that formula like this. Makes things a lot easier. Now I need to square it to get rid of any negatives. So my observed minus my expected squared. So the easiest way in Excel is to just go like this, equals my observed minus my expected, that's this column here, equals this column, squared. And to do that is actually a little harder. You have to go Shift 6 to get that funny little arrow thing up there and go 2, and it will square it. Or you could do this on the calculator if this is freaking you out. Copy down, and there you've got your values. Then I have to divide that column by that column. So again, I just go equals this column, which is observed minus expected squared, divided by my expected. So go the slash, the one that has the question mark on it, is your divide sign, and then click on the expected column that you want to divide it by, and then go equals 0 again, because it's 0 divided by 31 is going to be 0 in this case, but that's not going to be the same for all of these. 0 divided by 0 is actually going to be an impossible number. We might just have to say 0 there, and to keep on going down, copy it down again. There are your last two numbers there. Now, we have to add all these up. So this equals all of these added up. Whoops, I'm just going to make that easier. You can actually type it in. Sum of brackets, all of these. In other words, add all those up. Now it's going to have a tantrum there because of this little thing here. Change that number to 0, add them up. There you go. Now if these numbers are far too big for you and you want to make them smaller, here's a trick. You go up here, click on this little guy here saying I want to decrease my decimal numbers, and it will make them smaller for you. Okay? Now we have to know whether to accept or reject it. This is our chi-square number here, 0.09. We have to use this table here to accept or reject it. We want a 5% error or less. So we have to think, first of all, what is our degrees of freedom? How many rows did I take into account here? 1, 2, 3, 4. My degrees of freedom is 4 minus 1, which is going to be 3. So I go down here to 3, come across here, and I see whether or not my number is bigger or smaller than 7.82. Is 0.09 smaller than 7.82? Absolutely, which means that error is very low. I will accept it. Because 0.09 is much smaller than 7.82. So just remember, when you're looking for these degrees of freedom, you have to take the number of rows you did and take away 1. So the degrees of freedom is going to be 4 minus 1 equals 3. So I read across from the 3 here, find out what my 5% error amount will be. So with that many flies, my 5% error rate would be 7.82. My error rate was less than 1. So it's definitely got very low error in it. And that's how you do a chi-square analysis. You need to do that for your eyes over here. If you can't do the F2 generation because you don't have enough numbers, don't worry about it, just stick to your F1 generation. I'm actually going to see if I can pull up these formulas here for you to see so that you can type them in if you want to.